the domain of a composition, that's definitely the advanced objective of this section. I think finding the composition, that's not that bad, but finding the domain of the composition, that's quite advanced. Okay, so domain is set of x values set of x values f composed with g, which that little circle, of course, we're understanding it does not mean times. It means f of what? F of g of x. Okay. Now, what I'm going to do is partially compose, which in my book is just about as good as completely composing, f with g. F of anything is the square root of 90 minus that thing. What is the thing? Well, the thing is g of x. What is g of x? G of x is x squared minus x. Okay. This is the input of that's being input to f. Now, that is the composition in my book. You can clean it up, you can make it look better. In my book, that is the composition. Okay. Now, x can only be certain values because there are, I'm guessing there are going to be, it's going to be possible to come up with maybe some x values. I know that it can be done, that will make this whole radical undefined. Set of x values which are allowed. Because some x values are not going to be allowed, and they're not going to be in the domain. Okay, so this equation right here tells us that um, $90 minus this input here has to be greater than or equal to 0, okay? Because of the square root, okay? It's a radicand of a square root. You can't take the square root of a negative. You can't take the square root of a negative. So 90 minus the input has to be greater than or equal to 0. We'll subtract 90 from both sides. Negative of the input greater than or equal to negative 90. Divide both sides by negative 1. Input, if you divide both sides by a negative, you have to flip the inequality symbol. Less than or equal to 90. Input less than or equal to 90. What is the input? X squared minus x. X squared minus x less than or equal to 90. Okay. Now, we have to solve that inequality in order to know this domain, which in itself is it's one of the hardest problems that we do. And we had to do a lot of work just to get there. Okay. Now, subtract 90 from both sides, and you have x squared minus x minus 90 less than or equal to 0. Now, to solve that thing, this problem is a problem about domain. So it would be okay to solve it graphically if you're comfortable with that, Amy.
Yes, sir.
Okay, so x minus 10, x plus 1 is how we could, I'm sorry, x plus 9 is how we could factor the left-hand side, okay? And a graph of that would look like this. Okay, so I'm going to graph y1 equals x minus 10, x plus 9. Okay, that graph, well, let's see. We've got an upward opening parabola because the positive lead coefficient we have x-intercepts at, well, let's see, if you put a 10 right there, you zero out this factor. I'm just doing the graph. I could just put it in the calculator, but I'm just talking about the graph. You put a 10 in there, you blow up this factor. 10 minus 10 is 0. 0 times anything is 0. So the point 10, 0 is on the graph. Similarly, negative 9, 0. Actually, this is going to give us the answer. An upward opening parabola Okay. And so the question is, where in the horizontal, where, of course, that's the where, just like in the min and max problem and the increasing decreasing problem, the where is the x, okay? So where is the graph below or at? Graph at or below, at or below 0, at or below the x-axis. Well, that happens all in here because the graph is at or below. It's down there, okay? At or below. So that includes everything to -9, and it includes everything up to and including 10. So the closed interval, -9 to 10, and that actually is our answer. Okay, so